myself and Arun Kumar from SS College of Technology in the Department of BCB. So in this video, we are going to discuss about signal flow graph. So the signal flow graph in the control system is very useful to find out the number of loop has been generated in the control systems. Because if you are having multiple number of loop in the same path, then we can't able to get the original information. So that has to be removed by using this signal flow graph method. Introduction. So it is a graphical representation of algebraic equations. The block diagram reduction process takes more time for complicated system. So to remove the drawback, use the signal flow graph is done where the calculation of transfer function is by using a Mason's-Gaines formula without doing any reduction process. Basic elements. So if you are having a signal flow graph, then we have to consider the following elements. If it is not considered in the above elements, then we can't able to move towards the your signal flow graph to the destination. So we have to consider input node, output node, and mixed node. So mixed node is combining one loop with another one. Forward path. So it is a path from an input node to an output node that does not cross any node or more than once. Individual loop. So because while considering a forward path, the individual loop is the essential factor for getting an output, because only one loop is allowed for a forward path. If it is having more number of loop present in the forward path, then we have to eliminate the corresponding forward path by a non-touching loops. If a loop does not have any common node, then they are said to be a non-touching loops. So let us consider the following signal flow graph to identify these nodes. The nodes represented in the signal flow graph are Y1, Y2, Y3 until Y4. Y1 and Y2 are the input signal A. A will be the input, and the output is Y4. Y2 and Y3 are mixed nodes. Y2 and Y3. So in between the loop is a mixed node. Branch is a line segment which joins the two nodes. It has both gain and directions. For example, there are 4 branches in the above signal flow graph. The branch have a gain of ABC and minus D. So let us construct a signal flow graph by considering the following algebraic equations. So the algebraic equation is the equation which will be formed as a control feedback loop as well as the forward path gain. So it has to be followed based on the forward path executed until the loop may be joined with one another. So step 1, signal flow graph or a y2 equal to a1 y1 plus a2 y4. So it has to be followed by a12 into y2 y3 until a4, because based on the loop we can create a transfer functions. And second one is step 2, signal flow graph for a second equation can be written by y1 y2 y3 y4 y5 y6, because we are given in the sum as y2, so that it can forward as a y2 a2 into y2 plus same y3 into a3. So based on the equation we can write the and generate a signal flow graph based on the equations. So like that we can able to draw the signal flow graph based on the equations. Next one is complex signal flow graph. So in your graph, if you are having more number of equations present in a same time, so that the loop can be joined with one another, because the same equation a1 a2 or a3 maybe joined with one another loop, so that the equation may be forwarded to the another path by directions. The directions are the best one here, because if it doesn't have any forward path or backward path, the signal only decide. So if it is having a negative direction, then the loop will be executed in this direction only. So if it is in forward path, then the loop can be executed in forward path. If it is in reverse order, so then the loop will be generated within the loop. So like that, all the functions can be enabled based on the transfer functions equations. Conversation of block diagram into signal flow graphs. So if you want to convert your block diagram detection into signal flow graph, it can be achieved by the following ways. So let us consider an example of a block diagram detection technique. So in this loop, more number of blocks are adding with one another. It can be reduced based on the number of loops or number of non-touching loops. So it can be generated by, so in previous the loops are maybe passed by looping elements. It can be joined as a summing point also. Based on the summing point, you can generate the loop of the corresponding transfer functions. So if you're having summing point, then automatically the loop will be generated based on the direction of the block diagram detection. So like that, all the signals can be generated based on forward path or reverse path loop. So after finding the calculation of the signal flow graph, we have to use Mason's gain formula. So it is the formula which is used to identify the transfer function of the systems. It can be calculated based on the formulas. It is none other than that C of s by R of s, because it is a transfer functions. It can be calculated as a CS. Already we know that C of s is the output node, R of s is the input node, and the T will be the transfer function of the corresponding system. And the delta value will be calculated by 1 minus sum of individual loop gain. If it is having lot of forward path, then we can use it here, plus sum of gain product plus possibility of non-touching loops, because already we discussed that if you are having a non-touching loop present in the forward path, then we can use here. And next step is minus sum of gain product plus all possible of three non-touching loops, because in your forward path, if you are having three non-touching loop, you can mention here. So like that, all that values has been calculated by using this delta value. After finding the delta, we can substitute the delta value in this transfer function gain. After substituting all the values, we can able to calculate the corresponding values of the transfer functions. So like that, all the values has been calculated by using this signal flow graph. Thank you.